let's look at question number 6 from the 2022 AP Calculus BC exam. This will most definitely be the Taylor series question. I have not read the questions yet. I'm solving these in real time, and we will see how I do. So number 6, the function f is defined by that power series. That looks eerily similar to cosine. However, the denominator is not factorialized. All right. So for all real x, all right, so use the ratio test to find the interval of convergence so you don't forget to test those endpoints. So fairly straightforward question, not to be confused with easy, because there will be a lot of work here, but a straightforward question. We need to limit as n goes to infinity of the absolute value of the n plus first term, and I'm looking at my generic term over there. That'll be negative 1 to the n plus 1, x, and if I plug in n plus 1 for that, that'll be 2n plus 3, all over 2n plus 3, divided by the a sub nth term, which is times the reciprocal of the original, so negative 1 to the n, x to 2n plus 1. Hopefully you get a point for setting up the ratio. Then we start canceling stuff out. Now I'm going to cheat. I'm going to use different colors because I can do that. So I'm going to take that out. There are 2 more x's up here. So that's x squared, and that doesn't cancel. Negative 1 to the n will cancel all but one of those negative 1s. However, that negative 1 will be done away with because of the absolute value. So we now have the limit as n goes to infinity of x squared times 2n plus 1 over 2n plus 3. And we don't need absolute values because x squared is going to be positive, or at the very least 0. It'll definitely be non-negative. And this limit will approach x squared. And for the ratio test to show convergence, that will need to be less than 1, which will happen when x falls between negative 1 and 1. And now we have to test those endpoints. So now let's see what happens when x is equal to negative 1. We will have the series. If I plug in negative 1 for x, so I have negative 1 to the n times negative 1 to the 2n plus 1 over 2n plus 1. Oh, man. Okay, so that is negative 1. If you add those exponents, that's negative 1 to the 3n plus 1 over 2n plus 1. And this is n going from 0? Yeah, this is n going from 0 to infinity. Okay. I know it's going to converge. This one is going to be fairly easy to show convergence by the alternating series test. And to show that something converges by the alternating series test, you need to show that if you ignore the alternating aspect of it, you need to show that the terms approach 0 and decrease, and that's going to be fairly easy to do. So I'm going to say the limit as n goes to infinity of 1 over 2n plus 1 does indeed equal 0. And I need to show that the terms decrease, and you would show that in this case. We don't need to go through derivatives, but I'm also going to show that if I plug in n plus 1 for my n plus first term is indeed less than my nth term. Therefore, this converges by the alternating series test, converges for x equals negative 1 by the alternating series test. Okay, I'm going to shrink that up, give me some room to work next to this to test x equals positive 1. And x equals positive 1 is going to end up diverging. I can tell by looking at it, but the amount of work, when I kind of let out this disgruntled, oh man, a minute ago, I was anticipating the work to test x equals positive 1. So I'm going to come over here. And when I plug in x equals 1, we will have the series. Plugging in 1 is just going to be negative 1. Oh, wait. Hang on. I may need to do a double. So, oh, this is going to be sexy. Never mind. This is nice. This is nice. This is why you actually put pencil to paper and you work problems instead of trying to just anticipate what's going to happen. This is really nice. Okay, now I wanted to, usually when you test your endpoints, you very frequently get one of them alternating and one of them not alternating, which opens up other convergence tests that are needed. However, because this x is being raised to the 2n plus 1, we actually are going to end up with 2 alternating series tests. And so test x equals 1, that is also, and because I have the work for the alternating series test over here with the 1 over 2n plus 1, I'm not going to repeat that, also converges by the alternating series test. Therefore, the interval of convergence is -1 to 1, including both endpoints, and we're good. All right, number B, I may just go on to the next page. Show that f of 1/2 minus 1/2 is less than 1/10. F of 1/2 minus 1/2 is less than 1/10. So it's an error question. It's an error question. Let me see, I'm going to just start writing some stuff down here. So absolute value of f of 1/2 minus 1/2 is less than 1/10. And because this is a convergent alternating series, because this is a convergent alternating series, then I know that we're going to look for the first omitted term. And where I'm hesitant, what I'm thinking here, so I have f of x is this, x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus so on and so forth. What I'm trying to figure out is what I need to plug in. Oh, they're telling you f of 1/2, so we're plugging in 1/2 for x. Usually this piece right here, instead of giving you just a number, so f of 1/2, that's going to, okay, so here's where I was hesitating. I was trying to figure out what degree, what term are we looking at? What term are we looking at? And so I'm going to just think of this is a Taylor polynomial, and we are centered at 0. I could call it a Maclaurin, so whatever. This is a Taylor polynomial of nth degree of x, and that does give you f of x, and I need to achieve a 1/2 when I plug into this, when x is 1/2. So t sub n of 1/2 would equal, t sub 1, if I use the first degree of this thing, if I use the first degree Taylor polynomial, I'm really saying this really weird. I'm plugging in 1/2 for the very first x and the first x only. And so this is really just my first degree polynomial t1 at 1/2. And so we're going to use the first omitted term. And this is me game planning. I don't like the way this is working, looking on paper for a submitted answer on the AP exam. But I'm looking at what happens when I plug 1/2 into this. If I plug in 1/2 for that x, I would have 1/2 cubed over 3, which does clean up to 1 over 24. That is less than 1/10. So the first omitted term of that alternating series does yield a value less than 1/10, which is what we're shooting for. Now I just have to put that a little bit more formally on paper. So what I'm going to do is I'm going to start by declaring that the Taylor series for, actually I'm going to do this. I'm going to define, I'm going to say let t sub n be the Taylor series for f of x about x equals 0. So I could have just said the Maclaurin series. About x equals 0. And then I'm going to say t sub n is an alternating series whose terms decrease in magnitude. Boy, I hate writing this sentence, but sometimes I like to see this. Decrease in magnitude to 0. And so basically I'm just putting your alternating series test in words. Therefore, your error is going to be less than the first omitted term. I'm also going to say that t sub 1 of 1/2 is equal to 1/2, and this, which is your error, must be less than the magnitude of your very first omitted term, which will actually be T3, my third degree. Oh, actually, no, it's not the whole polynomial. I'm sorry. This is what happens when I solve these live and I don't polish up my work. So it's going to be less than the magnitude of the first omitted term, which will be negative 1/2 cubed over 3. And that is 1 over 24, which is indeed less than 1/10. Okay, I really stumbled my way through that as I was feeling my way through the problem. It's a fairly common question. I don't know what bowled me so much. I guess the fact that they just said 1/2 versus the third degree Taylor polynomial showed that the third degree Taylor approximation at 1/2, so something like that. The reason I could not write T3 of 1/2 is because T3 is not specifically only that third degree term, it's the sum, it's every term up to that. So that would have included the x. So I didn't want to include that. All right. Okay, so let's go on to part C. Let's go on to part C here. Write the first 4 non-zero terms and the general term for an infinite series that represents f prime of x. This one's not going to be too bad because f prime of x would be, we'll just do the derivatives of the terms that we're looking at up there. So that's going to be 1 minus, and I guess I'll do this in baby pieces, 3x squared over 3 plus 5x to the 4th over 4. No, 5. Minus 7x to the 7th over 7x to the 7th. Good job, Paul. The derivative of x to the 7th is 7x to the 6th over 7 plus, and sometimes I will differentiate, I think I will. I'm going to differentiate the general term as well. So x to the 2n plus 1, I'll bring the 2n plus 1 down, x, and then I'll subtract 1 from 2n plus 1. That's going to be over 2n plus 1, and that cleans up quite sexily. A little hiccup there. So I'm going to do that. Man, hiccups. So 3 over 3 is 1x squared. That'll be 1x to the 4th. That'll be 1x to the 6th. And my general term also simplifies. The 2n plus 1's cancel. Negative 1 to the n times x to the 2n. And there is part C. So that was a really nice question. Use the result from part C to find the value of f prime of 1/6. Well, that's really nice. These last two parts are really nice. F prime of 1/6. We'll just simply plug in 1/6 and use the result from part C to find the value of f prime. Oh. Okay. To find the value of f prime of 1/6. Is that a series I should know? Okay, this one did just get a little bit trickier. They didn't ask you to find an approximation. Is this a geometric series? This must be a geometric series. Okay. Yeah. Oh yeah. Yeah, it is. Okay. So there was my hesitation. All right. So when I first said, oh, this is going to be really nice. This is easy. I was thinking I'll just plug in 1/6 for the first 4 terms and stop and look at that beautiful answer. But that is actually an approximation. That is not the value. They say find the value of f prime of 1/6, which means we have to find the sum of all infinite terms. And in AP Calculus, there are only 2 series that you can find the sum of. One of them is a geometric, which this one is. The other one is if it happens to be a recognized Taylor series, which would be e to the x, sine x, or cosine x. This one, if you look at this is a geometric series with a first term of 1 and a ratio. If you look at this, I am multiplying each term. I'm multiplying by a negative 1/6 squared every time. 1 times negative 1/6 squared is 1/6 squared. Negative 1/6 squared times negative 1/6 squared is positive 1/6 to the 4th. So my ratio is negative 1/6 squared, which is the same thing as negative 1 over 36. And so the sum, f prime of 1/6, will end up being 1 over 1 minus the ratio. I would stop there on the AP exam, But I'm going to clean that up because I feel daring. 1 plus 1 over 36, that will be 37 over 36. And 1 divided by 37 over 36 is 36 over 37. And there is your value of f prime of 1/2. I'm going to write that f prime a little bit better. So there we go. That is all the questions of the 2022 AP Calculus exam. Hopefully I didn't make any mistakes. I'm sure you will let me know if I did.